In this last video about the ellipses, we are going to be practicing writing equations in standard form. If you remember from the first video, we talked about the standard form looking like this, where we've got our x's squared over a squared, and then y squared over b squared equals 1. Or the other way, we had the x's and y's switched. So this is the form we always want our ellipse formulas to be written in, because we can find the center very easily, and we can use the a's and b's to graph. So this is always the ideal form. So when it's not written in this form, we're going to have to manipulate the equation we're given and then do some division or maybe even some completing the square to get it back to that form. Okay, so this is the end goal for all of our equations. So in the example 1 here, we've got the equation 4x squared or 49x squared plus 4y squared minus 196 equals 0. What I would always suggest doing first is to move the constant to the other side. So we get 49x squared plus 4y squared equals 196. And the reason I always say that, one, we can always then divide by that number to make your equation equal to 1, but also because in the second example, we're going to have to do some completing the square, and you don't want that constant in the way. So if there's a constant, move it over, and then go ahead and start your next steps. So in this example, we've just got x squared and y squared. That's a good thing. So what that means is we can just do some division. So to get this equation equal to 1, we're going to divide everything by 196. And if you divide one thing by 196, you have to divide it all by 196. That's why I like to write it out separately so we don't forget. So that's going to give us 1 on the right side of the equation. And then I'm going to go ahead and reduce. So think of it like reducing fractions. If you have 49 over 196, that reduces down to 1/4. So the way I'm going to write this is x squared over 4, because in front of that x is now a 1. Then I can do the same thing for the other part of the equation. 4 over 196 reduces to 1/49. So this is the same as writing y squared over 49. The goal should always be to have no numbers in front of the x squared and y squared. That's going to make it a lot easier, and it's going to look like our standard form. So this is our final equation, and from here I could ask you to find the center, which would be 0, 0, and then I could ask you to find the a squared and b squared values. Now, in this case, you need to be very careful, because if I did ask you to find the a squared and b squared values, remember that a is always bigger than b. So this actually is written backwards. To put it in the correct format, I would write it as y squared over 49 plus x squared over 4 equals 1. That way you know the direction it's going, because this right here is our a squared value, and that right there is your b squared, since the b is smaller. So it's not super important in the end, but it will be important if I was asking you to graph or to give me specific values. All right. Now, example 2 requires a little bit more work, because if you notice, we don't just have x squared and y squared. We also have x's and y's, and we don't want to have multiple variables in our final equations. So this is going to require a couple different steps. Step 1 is still move c to the other side, just like we always have. So I'm going to add 59 over to the other side, and that's going to leave us with 9x squared, and then we'll have plus 4y squared minus 54x minus 8y equals 59. Step 2 would be to reorganize or reorder the equation. And what I mean by that is to group all the x's together and group all the y's together. So that's going to look like this. 9x squared minus 54x, and then I'm going to leave myself some space, and then I've got 4y squared minus 8y, and then equals 59. So now all my x's are together, and all my y's are together, and that's going to make it easier to work with. Now, the goal is to have something factored at the end. So because I have x squared and x, and I have y squared and y, to make this factorable, I'm going to have to complete the square. Now, this only happens when you have an x squared and an x, or a y squared and a y. If it was just x squared and y squared like the first example, then you do not have to complete the square. So this only happens on occasion, but we have to go back to remembering how to complete the square like we did last semester. So in order to complete the square, you first need to take the number in front of the squared term out. So if I work with the x's, so I'm just going to do this piece first. I'm going to factor out a 9. And that's going to leave me with x squared minus 6x, okay? And then to complete the square, if you remember, we're going to take the b value divided by 2 and then square it. So my b value is -6. So I take -6 divided by 2, and then I'm going to square that, which gets us 9. That 9 goes right inside our parentheses. What we did now is made this into something that is factorable, which is exactly what we want. Okay, now remember, when you complete the square, if you do something to one side, you have to do it to the other. So because I put a +9 here, 9 times 9 is 81. That means I'm going to add an 81 to the other side. And the reason for that is because I'm going to keep my equation balanced. So the goal is always to have a balanced equation. Now we're going to do the same thing with the y values. So I'm going to deal with the y's here. So first step is to take out the number in front. So that's the 4. And that leaves us with y squared minus 2y. So now I'm going to go through the completing the square process. So remember, take the b value, and then divide that by 2. That gets us -1. And then square it. That gives us +1. So +1 goes at the end. We multiply those two numbers together, 4 times 1. That means we're going to add a 4 to the right side of the equation. Okay, so now we've balanced our equation. We've completed the square. Now step 4 is to factor. Okay, so if I factor this, I get 9 times, this would turn into x minus 3 squared, which means x minus 3 times x minus 3. But remember, if it's the same thing twice, we can condense it into 1. Okay, and then plus 4 times y minus 1 squared, because y minus 1 times y minus 1 gets us that equation in green. And then equals, if I add 59, 81, and 4 together, I'm going to get 144. So now it's almost done. It's almost in standard form. The last step, like our first example, is to get the equation equal to 1. So I'm going to go ahead and I'm going to divide everything by 144. So divide this by 144, the y's and the x's. And now I'm going to reduce. So if I reduce 9 over 144, I get x minus 3 squared over 16. If I reduce 4 and 144, I get y minus 1 squared over 36. And then 144 divided by 144 is 1. And now we are finished. And again, this form is useful because we can find our center. We could also find the a squared and b squared values, which would help us to graph or to give us pieces of information about the type of ellipse that it is. So this example is a little bit more difficult because you had to complete the square. If you had any questions about any of the steps that I followed, please let me know. But the key here is remembering you complete the square when you have a squared term and a singular term together. Okay, so an x squared and an x, or a y squared and a y. That way you can factor it and then be able to divide at the end, just like in example 1.